Welcome to EDU World Space.
We're given this object that appears to be pivoted at point O, or point naught, and has a gravitational force, probably from its weight, acting through the center of it, which is presumably the center of mass. It has a couple forces acting on one end of it, and then some reaction forces acting down here at the pivot. And we're asked to figure out the necessary conditions for equilibrium of this. So we can just use Newton's laws to write. The first thing we can do is let's take moments about point 0 or point O, and that way our x and our y will not appear in the equation for the moments. So we do that, and we get that I'm taking positive to be clockwise. So Fg sub y acts has a moment arm here of L over 2 cosine theta. So this distance here. F sub x creates a moment, also a positive moment, and it has a moment arm of this distance here, which is L sine of theta. F of y has a moment, is going to create a moment in the counterclockwise direction, so we have a negative sign here, and its moment arm is this distance, which is L cosine theta. And that has to be equal to 0 for this to be in rotational equilibrium. We also have equations that for it to be in translational equilibrium. So the sum of the forces in the x direction, so f of x, if this is positive, f of x minus r of x has to be 0. And the sum of the forces in the y direction, which I forgot one here. The sum of the forces in the y direction, so we have f of y minus fg of y plus r of y equals 0. And we then have three equations here, and if say we were given well, we could as long as we only have three unknowns here, we could solve for them with the three equations. So if we were given a couple things, we could figure out the others. So if we were given, say, fx and fy, then we could figure out what the weight is and what the reaction forces are. Likewise, if we were given the reaction forces, we could figure out what the weight is and what these forces are. So as long as we are given two of these quantities, two of these 5 quantities, then we can solve for the other 3 using these 3 equations.